In this video, we're going to take a look at the fundamental principle of counting. How many different outfits could you put together using 2 sweaters, 4 pair of pants, and 2 pair of shoes? Well, let's draw a chart. We have sweaters, 2 of them. Let's just start with the first sweater. So let's start with sweater A. And then we have pants, 4 pairs. So we have 1, 2, 3, and 4. And then we have shoes, 2 pairs. And so if I match up sweater A with the first pair of pants with the first pair of shoes, or sweater A with the first pair of pants with the second pair of shoes, or perhaps we pick A with the second pair of pants and the first pair of shoes, or the second pair of shoes, sweater A with the third pair of pants with our 2 options for shoes, or sweater A with the last pair of pants with the 2 options of shoes. You can see that we have 8 options, and that's just with sweater A. We'd have the same amount of options with sweater B. So I would take 8 times 2, we'd have 16 total outfits. And again, because we have sweater A or B with the different pants and shoes. So this is the fundamental principle of counting, and it says that there are A ways of choosing one item and B ways of choosing another item, C ways of choosing a third item. Then the total number of possible outcomes is A times B times C. Let's see how that works with this scenario. We had 2 sweaters, we had 4 pants, and we had 2 shoes. 2 times 2 times 4 is 16, which is the same thing that we got by drawing out our chart. All right, so let's do some probability. The probability of an event is, of course, the number of ways an event can happen out of the total possible ways. Example 1, suppose a license plate can have 3 letters followed by 4 digits. Okay, and so y'all know that there are 26 letters in the alphabet. And when we're talking about digits, if we start with 0, then 1, 2, 3, all the way to 9, that's actually 10 digits. So if I have a license plate that has 3 letters followed by 4 digits, I'll have 26 options for each of those letters, 10 options for each of the digits. If I put this in a calculator and multiplied it, I would get 175,760,000 possible license plates. And again, we're multiplying all of these. And that is the fundamental principle of counting. How many license plates are possible that have no repeated letters or digits? So we can have no repeats. Well, I'm going to draw my 7 boxes. I know I'm going to be multiplying each of these boxes. All right, for the first letter, we have 3 letters. The first option, you'd have 26. Well, if you used a letter, then you only have 25 remaining. And if we used another letter, you only have 24 remaining. So you can see how each of these is decreasing because we're not repeating. Same thing happens with the digits. The first option, we have 10, then 9, then 8, then 7. If we multiply these all together, we have 78,624,000 options. So now, what is the probability that a randomly select license plate has no repeated letters or digits? So we're looking for the probability of no repeated letters or digits, and that's out of the total. So this is going to be 78,624,000 divided by 175,760,000, and if you put that in a calculator, that's about 0.447. Let's take a look at permutations. Example 2, I have 5 books I want to arrange in a particular order on a shelf. If I have 5 books, well, I have 5 options for the first book. If I place a book there, I have 4 books remaining. Then 3 books, then 2 books, then only 1 choice for that 5th book. If I multiply this together, I get 120 different ways. Okay, what if I only want to arrange 3 out of my 5 books? Well, then only 3 positions. The first option will have all 5 books to choose from. The second will have 4 books to choose from because you've already placed one. And then the third option, you would have 3 choices. If you multiply that together, you have 60 ways. Whenever you want to know how many ways there are of arranging some number of items, it's called a permutation. With permutations, order matters. Example 3, 7 flute players are performing in an ensemble. The names of the 7 are listed in the program in random order. How many different ways could the players' names be listed? Okay, so if I'm going to name all 7, we're going to be multiplying these. I have 7 options for the first name. Then I have 6 options for the next, and so forth. If I multiply that together, I have 5,040 different ways to list. In part B, now how many ways could we list them in alphabetical order? Well, there's only one way to list them in alphabetical order. In part C, if the players' names are listed in the program in random order, what is the probability they will be in alphabetical order? So we want the probability of alpha order out of the total. And that's just going to be 1 out of 5,040, which is a very small decimal, 0.000198. And the last question, after the performance, the players are backstage. There is a bench with only room for 4 to sit. Okay, I have 4 spots. We've got 4 places. Well, if the first player, the first seat has 7 options to choose from. If one person sits, then you'll have 6 people to choose from, then 5 people, then 4 people. If you multiply this together, 840 ways to sit those people.